Welcome to Chapter 10, Tuples and Dictionaries. This chapter introduces two more essential Python data structures. Tuples are like lists but immutable, and dictionaries store data as key-value pairs for fast, meaningful lookups. A tuple is an ordered sequence of elements that can be of different data types. Tuples are written with elements inside parentheses, separated by commas. You can store integers, floats, strings, and even lists inside a tuple. Like lists, elements are accessed using zero-based indexing. A very important rule: if you have a tuple with only one element, you must put a trailing comma after it. Writing round bracket 20, round bracket without a comma, makes Python treat it as an integer, not a tuple. Writing round bracket 20 comma round bracket correctly creates a single element tuple. Accessing tuple elements works exactly like lists. Use a positive index starting from 0 to access from the left, or a negative index starting from -1 to access from the right. You can also use slicing to extract a range of elements. An out-of-range index raises an index error. The most fundamental property of a tuple is that it is immutable. Once you create a tuple, its elements cannot be changed. Attempting to do so causes a type error. Because of this immutability, tuples are faster than lists and can be used as dictionary keys, which lists cannot. Tuples support the same operations as lists for reading data. You can concatenate two tuples with the plus operator, repeat a tuple with the asterisk operator, check membership using in and not in, and slice to extract a portion. All these operations return new tuples without modifying the originals. Tuple unpacking, or assignment, lets you assign several variables at once from a single tuple. Writing a comma b comma c equals the tuple 10, 20, 30 assigns each value to its respective variable in one line. This is a very convenient Python feature used frequently in practice. Tuples have only two methods, count and index. The count method returns how many times a value appears. The index method returns the position of the first occurrence. Built-in functions like len, max, min, and sorted also work with tuples, though sorted returns a list as output. Nested tuples are tuples that contain other tuples as elements. This creates a multi-dimensional structure. To access an element in a nested tuple, you use two indices, the first to select the inner tuple and the second to select the element within it. When should you use tuples instead of lists? Use tuples for fixed collections that should not change, like the days of the week or coordinates. Tuples are slightly more memory efficient than lists. And crucially, tuples can serve as dictionary keys while lists cannot, because dictionaries require immutable keys. A dictionary is a collection of key-value pairs. Unlike sequences indexed by integers, dictionaries are indexed by keys, which can be strings, integers, or tuples. Dictionaries are written with key-value pairs inside curly braces, where each pair is separated by a colon. You can create a dictionary directly using curly braces with key-colon value pairs, or using the dict function. An empty dictionary is created with just two curly braces. Keys in a dictionary must be unique and immutable. If you use the same key twice, the second value overwrites the first. To access a value in a dictionary, use its key inside square brackets. For example, student at name gives a run. The get method is safer because it returns none, or a default you specify, if the key does not exist, instead of raising a key error like direct square bracket access would. Dictionaries are mutable. You can change an existing value by assigning a new value to its key. You can add a completely new key-value pair simply by assigning a value to a key that does not yet exist. And you can delete a key-value pair using the del statement. The in operator on a dictionary checks for key existence, not value existence. Writing name in student asks whether name is one of the keys. The len function returns the total number of key-value pairs. Dictionaries do not support slicing or the plus concatenation operator. You can traverse a dictionary in three ways. A standard for loop iterates over the keys. Calling dict.keys explicitly returns a view of all keys to loop over. Calling dict.values gives access to all values. And dict.items returns each key-value pair as a tuple, which can be unpacked in the loop. The keys, values, and items methods return special view objects. These views are not separate copies. They reflect the current state of the dictionary. If you add or remove a key after creating a view, the view automatically shows the updated state. The update method merges another dictionary into the current one. If a key exists in both dictionaries, the value from the other dictionary overwrites the original. The get method with a default value is the safe alternative to direct key access when you are not sure if a key exists. The pop method removes a key and returns its value. If the key does not exist and no default was provided, it raises a key error. The clear method removes all key value pairs at once, leaving an empty dictionary. The dictionary itself still exists. It is just empty. Practical use of dictionaries is counting word frequencies. For each word in a sentence, check if it is already a key. If it is, add one to its count. If it is not, add it as a new key with a count of 1. This builds a complete frequency map in a single pass through the text. A nested dictionary has dictionaries as values. For example, a school dictionary might have class names as keys and each class's section details as nested dictionaries. To access a nested value, chain 2 square bracket accesses. School at class 1 at A gives the number of students in class 1 section A. Lists use integer positions to identify data, which can be confusing. Dictionaries use meaningful keys, making code self-documenting and easier to understand. Dictionary lookups are also extremely fast. They are performed in constant time, regardless of how many keys the dictionary has. Just like lists, assigning one dictionary variable to another does not copy it. Both point to the same dictionary. To create an independent copy, use the copy method. For dictionaries with nested objects, use copy.deepcopy from the copy module to ensure a completely independent duplicate. Let us compare tuples and dictionaries. A tuple like Arun, 1, 95 stores data positionally, requiring you to remember that index 2 means marks. A dictionary like name Arun, roll 1, marks 95 is self-explanatory. Dictionaries are more readable, while tuples are more compact and memory efficient. Chapter 10 covered 2 fundamental data structures. Tuples, immutable ordered sequences in parentheses, are ideal for fixed, unchanging data and can serve as dictionary keys. Dictionaries, mutable key-value mappings in curly braces, provide fast, readable access to structured data. Together with lists, these form the core of Python's data handling capabilities.